back to Magic Tutorials for Chemistry. We will discuss about the crystal field splitting in octahedral and tetrahedral complexes. So, there are 5 d orbitals, right? There are 5 d orbitals. So, you can see here they are dxy, dyz, dxz, dx square minus y square and dz square. So, out of this 5 d orbitals, dxy, yz and dxz, the lobes lie between the axes, correct. You can see here the x axis and the y axis. So, the lobes they are lying between the axes. Same way in dyz, between y and z axis the lobes are lying. Same way in z and x, dzx, the lobes are lying between the axes. So, I have written here between the axes, all the 3 between the axes. But in dx square minus y square and dz square, you can see the lobes, they are on the axis. See, they are on to the x axis, they are on to the y axis. Here they are on the z axis. So, dxy, yz and zx, they are between the axis, and dx square minus y square and dz square, they are on the axis, they are present on the axis, correct. Now, we know that when ligands approach the central metal atom, when the ligands they are approaching the central metal atom, at that time repulsion takes place. Repulsion takes place. Now, why repulsion is taking place? Because we know that the ligands are negatively charged, right? Ligands are negatively charged, and the metal, it has a d orbital which has electrons. In the metal, in the d orbital of the metal, electrons are present. So, negative and negative, what will happen? Repulsion will take place, right. Now, what you need to remember here is, when the ligands approach the central metal atom, correct, repulsion takes place between the ligands and the electrons. So, at that time the metal's d orbital, it splits into 2 levels. It splits into 2 levels. So, let us see now what happens in case of octahedral complexes. So, in octahedral complexes, in octahedral complex, the ligands approach along the axis, that means they are coming through the axis, correct. So, they are coming through the axis. Look here now, dx square minus y square, they are on the axis, dz square is also on the axis. So, the ligands are coming along the axis, So, what will happen? Which is along the axis here? Eg, that is dx square minus y square and dz square, we call them as the Eg level, correct, on the axis. So, dx square minus y square and dz square, we call them as the Eg level, right. Therefore, when the ligands approach along the axis, which axes are present? These two orbitals are present, which is called as the Eg level. So, therefore, more repulsion takes place. Repulsion will be more. Correct. If repulsion is more, therefore, higher energy level, Eg goes to higher energy level, correct. So, that is in case of octahedral complex. In octahedral complex, the ligands approach along the axis. So, we know along the axis which orbitals are present? dx square minus y square and dz square. These both orbitals together, we call it as the Eg level, correct. So, this Eg level, in the Eg level, repulsion will take place, more repulsion will be there, and Eg goes to the higher energy level. Therefore, how the splitting occurs in octahedral complexes? Eg will be at the higher level, correct? Eg will be at higher level, and T2G, that is triplets, T2G triplets, that is dxy, dyz and dxz, they possess less energy, so they are at a lower energy level. Hope this is clear to you. Let us discuss what happens in tetrahedral complexes. So, in tetrahedral complexes, in tetrahedral complex, the ligands approach between the axes, from between the axes, correct, between the axes. So, which orbitals are present between the axes? dxy, dyz and dxz. So, repulsion will take place, more repulsion will be there, repulsion will be more here, correct. So, these axes together we call it as T2G. So, T2G will possess higher energy, because of more repulsion. So, that is in case of tetrahedral complexes, correct. So, tetrahedral complexes T2G possess higher energy. So, T2G, that is dxy, dyz and dxz will be at higher level because it possesses high energy, and Eg, that is dx square minus y square and dz square, they possess lower energy, so they are at the lower level, correct. Now, why the repulsion it is taking place? Because the ligands are approaching between the axes here in tetrahedral complexes. So, what is the difference in both? That is, in octahedral T2G it is at lower energy level, and in tetrahedral complexes Eg it is at lower energy level. So, hope it is clear to you why Eg level possesses a higher energy level in octahedral and lower energy in tetrahedral. That is all because of the repulsions between the ligands and the electrons present in the d orbital of the metal. So, thanks for watching.